Hello. This is going to be a tutorial on how to use Desmos to teach you if you're doing your algebra right. Traditionally, when we do algebra to solve an equation, we don't know if we did the solution, found the correct solution until the very end. If we make one single mistake in the process of finding a solution, then our result is going to be incorrect. Using Desmos, we can not only determine whether or not we are getting the correct solution, but we can tell one step at a time if we applied our properties correctly. So did we multiply, well, let's just look at this example right here. In this example, we have 3/4 plus 2x equals 1/8 x minus 8. And our first step for fraction busting is to multiply both sides by 8. Now what Desmos is going to do is it's going to tell me whether or not I multiplied by 8 properly. So first things first. What I'm going to do is take the left-hand side of the equation, 3/4 plus 2x, that's right here, 3/4 plus 2x, and write it as a y equals. So this is all the solutions to the equation y equals 3/4 plus 2x. Then I'm going to take the other side of the equation, which is 1/8 x minus 8, and I'm going to enter that as a y equals, and that gives me the other line, the blue line. All of the points on this blue line are solutions to the second equation. Right here happens to be solutions to both equations simultaneously. What I'm interested in is what value of x can go here and here that will make the y values the same. So if x is negative 4 2/3, then both y values will be the same, and that's going to be negative 8.583 approximately. So that is the solution. That 4.667, or that negative 4 2/3, that's the solution to the equation. It's definitive. Now let's go back and look at the algebra. In the first step, I multiply both sides by 8. I end up with what I did here. I took 3/4 of 8 and got 6 plus 2x equals x minus 8. Some of you might see that there might be something wrong with that. What I'm going to do is put in my two new equations as y equals. So the first one will be y equals 6 plus 2x, and my second equation will be y equals x minus 8. So here's the line y equals 6 plus 2x, and here's the line y equals x minus 8. As you can see, the intersection of the purple and green line is not the same as the intersection of the blue and red line, which means I must have made a mistake. Here's what happens. I've now found a new solution, and that new solution is negative 14. So if I was to continue solving this equation, I would find x equals 14, and I would think I was right. But x equals negative 14 is not the solution to the original given equation because I made a mistake here. So the next order of business is, Desmos just told me, Mr. Guyette, you made a mistake. Now I have to find out what mistake I made. So if you have already recognized that the mistake that I made here is I failed to distribute. I didn't distribute the 8 on either side of the equation. So that teaches me something. That says, oh yeah, got to remember when I multiply, I have to multiply every term by the same amount. So I cross that out and I distribute properly, and I get 6 plus 16x equals negative x minus 64. So let's take a look and see what Desmos says about that. First, we'll get rid of these two and remind us of what our solution is supposed to be. It's supposed to be negative 4 2/3. So now what I'm going to do is I will enter in 6 plus 16x, and then I would also enter in x minus 64, not 8. So I get rid of the first two original lines, and then I put in the new lines, and I find out where they intersect. I can't even see the other one. Oh, there they are. Look at this. Where do they intersect? When x equals negative 4 2/3. Just to point out, the blue and the red intersect. Let's get rid of that guy. The blue and the red intersect at the exact same spot. So this negative 4 2/3 tells me that I am on the right track, that these two equations are indeed giving me the equivalent solution that I'm looking for. So let's carry on with the algebra process then. So I now have 6 plus 16x equals x minus 64. Next, I get 6 plus 17x equals negative 64. 16x, 1x, 17x, I add them together. So I go back to Desmos and I enter this in. So instead of 6 plus 16x, I'm going to have 6 plus 17x. And instead of x minus 64, I'm just going to have negative 64, so we'll get rid of that x piece. And then I find the point of intersection. It's negative 4, but it's not negative 4 2/3, so it looks like I'm wrong again. Go back. Why am I wrong? Why do I not have negative 4 2/3? The answer, of course, I added x to both sides instead of subtracting x. So I cross that out. I start over. I subtract x the proper way. And now I have 6 plus 15x equals negative 64. Go back to Desmos. 6 plus 15x. Now look at my intersection. It's negative 4 2/3 like it was supposed to be. We can continue with this process for every step in our algebra. The next step was to subtract 6 from both sides. So now I have 15x equals negative 70. So I'm going to write this as 15x. And write this as negative 70. Same solution. And then the next step, divide both sides by 15. So now I'm just going to have x. And I'm going to have 70 divided by 15. Well, there's our solution. Still there, same number. And finally then, well, that's all I have to do is reduce. And so did I reduce correctly? My work says 14/3. So I changed this to 14 over 3. Oh, same solution. It means I'm good. And I also made that negative 4 and 2/3. There it is, the solution. Oh, wait, what? I messed up. Oh, this should have been minus. Boosh. There it is. Okay, so if we just review quickly, if I take the left-hand side and the right-hand side and put those into Desmos, find the point of intersection, the x-coordinate will be the solution to the equation. Every time I make a move, multiplying both sides, adding both sides, whatever I do, I can enter in the new values as two unique equations and just make sure that the x's stay in the same spot, or the x intersection point stays in the same spot as it did originally. So here's what I had originally. And here's what I have at the end. Same intersection point. So thanks for watching.